We have seen and will focus in this class on two standard forms for lines. You will need to be familiar with both. It is my expectation. Okay. First, there's the slope-intercept form. It is perhaps the one that students tend to be drawn to more because it just has what seems to be fewer parts in it, right? Y equals mx plus b. I'm going to make a couple comments about when is this form better than the other. When is this? What's useful for this form? So, if you have an equation that's given in this form, it is convenient to graph. See the previous example we just did. We looked at y equals negative 5 halves x plus 4. It was convenient to graph. Okay. Here's the thing. Let's say you need to write an equation for a line. This is the form to use if you are given the slope and the y-intercept. This is why this is called the slope-intercept form. If you are given the combination of the slope and the y-intercept, this is the most convenient form to use. What about the other form of a line? So that was the point-slope form. As a reminder, it was y minus y1 equals m times the quantity x minus x1. What is this form good for? If you are given an equation that's in this format, it is convenient to graph. We're going to see an example in just a moment. When else is this form useful? Well, let's say you need to write the equation for a line. So you should use this format if you're given anything except the combination of slope and y-intercept. And I really mean this, anything other than that combination of slope and y-intercept. Okay? So how would you, first of all, just to talk about how would you graph y minus 6 equals 2 times quantity x minus 3. You could convert it to y equals mx plus b form. You could, distribute the 2, add 6 to both sides, all that kind of business. You could do that. But it's actually easier to notice that this is already in point slope form and say, look, based on the form, the line must go through 3, 6, and the slope is 2. Right? So from drawing the point 36 and then do that rise over run of 2 over 1, that'll take you to the point 4, comma 8, and then between those 2 points, just draw a straight line going through those 2 points. Okay, that is probably the fastest thing to do instead of converting it to y equals mx plus b format. Now, I want to really dig into this thing about if you're given the slope and the y-intercept, and you need to write the equation for the line, then use slope-intercept form. Use y equals mx plus b. If you're given any other combination of stuff, and I really mean it, any other combination of stuff, then the point-slope form is always faster. So what about this example? So find an equation of the line going through these two given points. Okay, so we were not given the slope and the y-intercept, right? The only time slope-intercept form is faster is when you're given the slope and the y-intercept. So in this problem, the point-slope form is faster. Even if you're more intimidated by it, it is a little bigger looking, but it's not that much bigger looking. Okay, y minus y1 equals m times quantity x minus x1 will be faster. Okay, so when you're given slope and y-intercept, y equals mx plus b is faster. In any other scenario, y minus y1 equals m times quantity x minus x1 is faster. I'd like to try to convince you of this. So check it out. Let's compute the slope, right? So whichever form you use, both formats of a line have an m, and so we should compute m. You're given 2 points, so you can compute m, right? So change in y over change in x, 5/4. Sorry, little typo here. This should be so 9 minus 4 over 2 minus negative 2, so 5/4. Okay, I'll fix this one re-uploading. Here's the point. You have a slope. You have 5/4 as a slope, and then we have a point as well. In fact, you have 2 points. So you have a point and a slope. You actually have 2 points and a slope. So just pick one of the points and a slope and plug it into the point slope form. You have y minus 9 is equal to 5/4 times the quantity x minus 2. Done. If you were to do the slower method, you would, just to point out all the details, you would compute the slope. If you really insist on using y equals mx plus b, what you do is now that you know 5/4 is the slope, you'd write y equals 5/4 x plus b. Then what you would do is you would temporarily plug in one of the points, maybe 2, 9. So you plug that in for x and y temporarily, and then you'd have to solve for b. And let's see, so you'd simplify, 9 equals 5 halves plus b. You'd subtract 5 halves on both sides. I already also skipped a step of writing 9 as 18 over 2. So then you do 18 over 2 minus 5 over 2 is 13 over 2. That's b. And I did mention here you temporarily plug in x and y is 2 and 9. You then need to go back and unplug in 2 and 9. So now that we know what b should be, we now know that b is 13 halves, you go back to y equals 5/4 x plus b, that form where we didn't plug in for x and y now, and then you have y equals 5/4 x plus 13 over 2. This is quite slow. compare. In fact, I even skipped some steps in the slower work. So compare the faster work to the slower work here. I really insist on thinking about being strategic. So you have to get over this y equals mx plus b. I get that people like that a little because it looks a little shorter, and it is a little shorter looking. But if you try to apply the slower method, look at how much slower it is than the faster method here. So it is important to get used to both forms of a line. Okay, so here's the thing. What if you need y by itself? There are certain questions that could get asked where you need to solve for y. Even in that case, I think sometimes people think that y equals mx plus b is faster. What world is this still faster? Because take a look. If all you need to do is solve for y, take a look at y minus 9 equals 5/4 times the quantity x minus 2. Just add 9 to both sides. Then you have y by itself, right? So it's still not faster just because you need y by itself to use the slower form, right? Really, in this case, if you have 2 points, it is going to be faster to use the point slope form because you've got to compute the slope anyway, and then right away you have a point and a slope. So apologies for this little typo. The 1 that's right there should be a 2, but other than that, I hope you're really noticing which form is faster and which form is slower here. In fact, to really go through this, this is the interactive question. It's not to actually write equations for lines here, okay? It's just to talk about if the task is to write an equation for a line, then given what you're given in each question here, which is faster. So if you're given the 0.38 and the slope 9, is it faster to write in slope-intercept form or to write in point-slope form? Second question, if you had slope 7 and y-intercept 2, what's faster, slope-intercept form or point-slope form? What if you're given slope 7 and x-intercept 3? What's faster? What if you're given 2 points? What's the faster form? What if you're given slope 7 and 0.99? Which is the faster form?